In this example, we are required to find the time constant for the circuit shown in figure for charging of this capacitor when we close down the switch. Here you can see that in the circuit we are given with 2 batteries and 4 resistances. If we close down the switch, a current will flow through the capacitor and that will be responsible for charging the capacitor. If we wish to find out the time constant for the circuit for charging of capacitor, we need to use the concept of equivalent battery by using Thevenin's method. So for the same, we remove the capacitor from the terminals A and B and we redraw the circuit like this. Here you can see these are terminals A and B which are open from where capacitor is removed, and here we are taking the switch to be closed. This is 2V, this is R. Here also resistance is there, this is R, and another resistance is also connected over here which is R. Now in this situation, if we wish to reduce the whole circuit in form of an equivalent battery, we can calculate the internal resistance first for the circuit. And for this internal resistance AB, we can write, in this situation, these batteries can be taken as ideal batteries and these can be replaced by their zero internal resistance, or we can replace these batteries by straight wires. So here we can see this resistance will be in series combination with this resistance, that will become 2R, and this 2R resistance is in parallel combination with this resistance R, and this group is connected in series combination with this resistance R. Just have a look very carefully. So here the resistance between the terminals A and B can be written as this 2R in parallel with R. So this 2R connected in parallel combination with the resistance R, and this group is connected in series combination with this resistance R. So here the resistance across the terminals A and B can be written as 2R. In parallel we can write 2R multiplied by R upon 2R plus R, and this is in series combination with the resistance R. So here this RAB becomes, this can be written as 2R by 3 plus R, which can be finally written as 5R by 3. So this circuit can be finally reduced across terminals A and B in a manner that there will be a single resistance which is 5R by 3 and a given EMF connected, equivalent EMF connected across terminals A and B. Just to solve this problem, I don't need to calculate the open circuit potential difference across A and B in the given circuit, because I don't need the value of E equivalent. Here I replace the capacitor C which I have removed from the original circuit, and here I can see if the switch is closed, this capacitor is connected in series with the resistance 5R by 3 along with the equivalent battery. So when the current is flowing, this capacitor will be charged through this resistance. So we can directly write the time constant of this circuit to be equals to this tau can be written as RC, which can be written as 5RC by 3. That will be the answer to this question. If in this problem we are required to calculate the charge on capacitor as a function of time, in that situation I need to calculate the value of E equivalent, and then I can directly use the relation of charge on capacitor as a function of time in case of series RC circuit, of which transient analysis we already done.